Hello everyone. Let's interpret position time graphs and velocity time graphs together and know what do they say. But before that, I would advise you to check out this video on understanding motion in one dimension graphically. We have a displacement time graph or position time graph. Just replace the position or displacement with velocity on y-axis to get a velocity time graph. The slope of these graphs is y-axis over x-axis. But in position time graph, y-axis is displacement and x-axis is time. Therefore, the slope gives rate of change of displacement, which is velocity. And in velocity time graph, y-axis is velocity and x-axis is time. Therefore, the slope gives rate of change of velocity, which is acceleration. In short, displacement over time is velocity and velocity over time is acceleration. Thus, you can easily translate from position time graph to velocity time graph. All you have to do is just replace the body's position or displacement with velocity and its velocity with acceleration. If the line is parallel to time axis, then angle between this line and the time axis theta is equal to 0 degree. In position time graph, it means that the body is at rest and therefore has zero velocity. And in velocity time graph, it means that the body is moving with constant velocity and therefore the acceleration is 0. If the line is perpendicular to time axis, then the time does not change. The body is changing its position and possesses infinite velocity, making the acceleration infinite as well. Can any body travel within no time? This is practically not possible. The line with constant slope or theta represents uniform velocity and uniform acceleration of the particle. That is, the velocity and acceleration is going to be constant throughout this motion. The line bending towards position axis with increasing theta shows that the body has increasing velocity and increasing acceleration. The line bending towards time axis with decreasing theta represents that the velocity of the body is decreasing and possesses a negative acceleration, which is also known as retardation. The line with negative slope where theta is constant and greater than 90 degree indicates that the body has negative displacement. That is, the body returns towards point of reference. The velocity of the body is constant but negative, and the graph also represents that the body has positive initial velocity and acceleration is constant but negative. Let's have a look at few special types of position time graphs. The straight line segments of different slopes represent the variable velocity. That is, the velocity of the body changes after certain interval of time. Can a particle have two positions at one instance of time? No, this is not practically possible. Here the curve represents that the body is coming towards origin initially and after that it is moving away from origin. Note that if the graph is plotted between displacement and time, then it is always an increasing curve and it never comes back towards origin because distance never decreases with time.